Hello friends. Now today we will study what is the meaning of Poissons ratio. I'll write P-O-I Poissons ratio. ठीक है? Here we represent it by this mu. In some other books they represent it like this nu. Right? This mu or nu is equal to lateral strain, lateral lateral strain per unit longitudinal strain. Per unit longitudinal strain, right? This is known as mu. Now I use this mod signs because it will be a positive symbol. However, lateral strain, what is the meaning of lateral strain? Lateral strain means if we pull it from these two sides, we apply force P on both the sides. Now this material will elongate like this, right? The material will elongate, but it's this particular dimension will reduce from this to this. So this particular strain in lateral direction is known as the lateral strain, right? Now if I know that this original length was L, and after application of force this dimension will become L plus del L, so I can find out the strain in x direction. Let it be x and let it be y, right? Now what will be the lateral strain in y direction? That will be mu time of longitudinal strain, right? Longitudinal strain means strain in the direction of applied force. So what will be lateral strain? Lateral strain, I write it ls, as it will be mu times longitudinal strain, mu times longitudinal strain, right? So this is the first thing, and this is a very important formula. This formula will utilized in every expression, right? So now longitudinal strain is equal to lateral strain is equal to mu times longitudinal strain. Now we know that E is equal to stress by strain. Now what will be the strain? Strain will be equal to stress divided by E, right? The strain will be like this. So what will be longitudinal strain? Longitudinal strain will be mu into sigma by E. We will use this particular formula too much. In almost everywhere we will use this particular formula. Here we will call it sigma x because load is applied in x direction, and this is in this direction, right? Now the strain of ductile material, mu of ductile material is greater than mu of brittle material, right? This is one thing. Means ductile material has more lateral strain than the brittle material. For metals, for all kind of metals, mu varies from, what is the range of mu? We want to know what is the range of mu. Mu vary from value of 0.25 to 0.42, right? This is for metals. Theoretical range जो है, theoretical range for mu is theoretical range is 0 to 0.5. Now we will see that for which material, for some of the material, what is the value of mu. Let me clear this complete. Here I'll write glass. The value of mu for glass vary from 0.01 to 0.1, and for concrete the value is vary from 0.1 to 0.2. For metals, the value vary from 0.25 to 0.42. For pure elastic rubber, or you can say natural rubber, it is equal to zero point 0.5, right? So you can remember these values, because sometimes we use this. I will solve some questions where one will ask that whether this particular material is a metal or concrete or glass. Then by solving those questions we find the value of mu, and from the value of mu we are able to identify that whether this material is what kind of material it is, right? So it was all about Poisson's ratio and its usage.